Let's look at some applications of linear systems, starting with geometry problems. The first example says a rectangular parking lot has a length that is 10 feet more than twice its width. The perimeter of the parking lot is 620 feet. What are the dimensions? First thing you want to do on any kind of problem, especially a geometry problem, is you want to draw a picture. Label L and W. It's going to tell you, the problem will, something about either L or W. In this case, it says the length is 10 feet more than twice the width. So the length is 10 more than twice the width. Since we're going to solve this problem using a system of equations, there is our first equation. Our first equation is L equals, I'm going to turn it around, 2W plus 10. Same thing as 10 plus 2W. That's one equation. Now I need a second equation, and that's going to come from the fact that we're talking about perimeter. And we know that the formula for perimeter is P equals 2L plus 2W. So to get my second equation, all I do is take that 620 and I write 620, which is the P, I'm substituting for P, equals 2L plus 2W. I now have a system of equations, and I have the option of using the substitution or the elimination method. Because this equation is already solved for L, it makes a perfect substitution equation. So I'm going to substitute that L right there. So that's going to give me 620 equals 2. Take out that L, put in what it's equal to, 2W plus 10, and then plus 2W. Or 620 equals 4W plus 20 plus 2W. 620, combine like terms, 6W plus 20, and now we're going to solve for W, subtracting that 20, and I get 600 equals 6W. Divide both sides by 6, and we get W equals 100, and this is feet. So instead of the point of looking for a point of intersection and there being a width and then a length, we're just going to write width and length because of the application in the context of the problem. It being a point of intersection doesn't really make sense. So the width is 100 feet. To find the length, I go back to my substitution equation, and I know that the length is equal to 2 of whatever I found for W plus 10, or L is 210 feet. That's a pretty simple problem, a pretty easy application of systems of equations. So let's look at the second type of problem for systems of equations. That's a money problem. Most of these are they're structured very much the same. So they're going to give you information about two different costs. So let's read this one. It says, for the 2008-2009 National Hockey League and National Basketball Association seasons, 2 hockey tickets and 1 basketball ticket purchased at their average prices would have cost $148.79. Now, I don't know about you, but there's a lot of words in that sentence, so you have to learn how to pare that down. And then it goes on to say 1 hockey ticket and 2 basketball tickets would have cost $148.60. So we're looking for the average ticket prices for the 2 sports. So what we're going to do is we're going to say let H equal the cost of 1 hockey ticket. And we won't be too creative here. We'll say let B equal the cost of a basketball ticket. And then from here, we're just going to translate the 2 sentences that you were given about the combination of those tickets. So the first sentence says 2 hockey tickets and 1 basketball ticket right there. So I'm going to write 2H plus 1B equals $148.79. That's what the problem told me right there. And then that's my first equation. My second equation is going to be 1 hockey ticket and 2 basketball tickets. So right there is my second one. 1 hockey plus 2 basketballs equals 148.60. I could use substitution here because I could either solve this first equation for B or I could solve the second equation for H. I'm actually not going to. I am going to use the elimination method just to show you that again. And so what I'd like to do is eliminate the H's, which means I need to multiply this second equation by -2. Why -2? Because then that will make the coefficient on H a -2 and put that with the positive 2H up here to make the 0. So the first one doesn't change. 2H plus 1B equals 148.79. And then the second one becomes -2H minus 4B equals, now we're going to put, I'm going to bring this calculator right over here so you can kind of see it. I don't know if you'll be able to see my key entries or not, but we'll give it a shot. I'm going to put 148.60 times -2, and we have -297.20. So -297.20. And since that was hard to see, I don't think I'm going to bring that into the picture anymore. I'll just do the calculation, and you can do it with your own calculator. Now I'm going to combine those two equations. 2H minus 2H is a 0. 1B minus 4B is -3B. And then I have a -297.20 and a positive 148.79, and what that makes is a -148.41. I now am going to divide both sides by -3, and I get the cost of the basketball ticket is $49.47. By the way, a negative divided by a negative is a positive. The cost had to be positive. So if you ended up with a negative number, you've done something incorrectly. So there's the cost of 1 basketball ticket. Now, because this is the elimination method, I don't have that substitution equation to make it easy to go back. So I'm just going to go back to my first equation and substitute in what I found for B. So 2H plus what I got for B, 49.47 equals 148.79. I am going to subtract the 49.47 from both sides, so I have 148.79 minus 49.47, which gives me 2H equals 99.32. We now divide that by 2, and you end up with the cost of a hockey ticket was $49.66. So that is an example of 2 application problems. The first is the geometry problem, and now the money problem.